Hi, my name is Harman Singh and my project is Physics Behind Xerography. What really motivated me to focus my project on the copying machine itself was my experience in my dad's workplace last summer, and then the copier there basically was used more than once a day, and I was fascinated as how the copier knew exactly what I needed to copy, and this curiosity drove me further to research and present my project on how a copying machine functions in this slide set. In order to fully understand how a copying machine works, we must first understand electric forces and electric fields. Charges itself exert forces on one another when they are either stationary or moving. Either attraction or repulsion is going to be experienced when there are two charges present. If there is a positive charge and a negative charge present, attraction is going to be experienced between both of them. When similar charges, for example positive and positive, repulsion is going to be experienced. Electric field is basically the direction of the force that would be present on a positive catch charge being placed near the two source charges. In order to calculate electric force, we can use the equation that is listed on this slide. Kc times Q1 times Q2 divided by R squared, all multiplied by R hat. Kc is the Coulomb constant, Q1 is charge 1 and Q2 is charge 2, and R squared, in which R equals the distance between the charges that are separated, and R hat is the unit vector. The picture on the right shows the electric field, so basically if I were to place a positive test charge anywhere near these particles, the arrows indicate which direction the positive charge will go. And the picture below that represents the electric forces that are experienced given the charges of each individual particle. Given the electric force equation that is listed on the slide, we can calculate the electric force that is experienced. For example, if two charges of opposite signs can be calculated using that equation, where Q1 will represent the proton, where Q2 will represent the electron. Kc is just a constant, and the R hat equals 1 in this scenario because force is experienced only in the x direction. We can then plug in our numbers into the equation and get force electric equals negative 9.23 times 10 to the negative 28 newtons, which makes sense because these are relatively really small charges. Now that we have a good understanding of electric fields and electric forces, we can understand the process behind a copying machine. Initially, we insert a page into the copying machine and it is brought down to the photosensitive drum via a roller. Then a halogen lamp directs light onto the page. The light is reflected off of the areas around the letters on the page towards the drum. The drum contains a coating of selenium, which is a semiconductor. The negative charges on the areas of the drum that experience the reflected light from the areas around the letters gets discharged. The negative charges on the areas of the drum that didn't experience reflected light overall remain present on the drum, which then results in an outlining of the letters that was present on the page onto the drum. After the outlining of the electrons on the page is done that represent the letters, the drum then rotates to the toner, which is positively charged. The toner particles attract to the negative charge on the drum. The toner particles are basically the ink, which are positively charged, and the drum then rotates towards the roller. The roller is basically bringing in an empty piece of paper that is already electrically charged, so negatively charged, in order to attract the positive charges on the drum that is already present there because of the toner particles. This is where electric forces are occurring between the piece of paper and the toner particles. Paper then proceeds towards a hot roller that fuses the toner particles onto the paper. This is why when the page comes out of the copying machine, it is so warm. And this is my works cited page.